All right, this is assignment 1-2. Here we go. So question number 1, let me write here. Take out a piece of paper like me, write the title down, show your work, be organized as much as you can. Here we go. So first step is, can you evaluate a function? I know you can. Plug in 0 for 3 and the answer is -2. Sometimes you have to think a little bit more about it. Plug in -3. So 3 times -3 is -9, take away 2. F at b, what does that mean? That just means put in b instead of x. Haha, that should be a 2. So put in b, so it becomes 3b, take away 2. And then d, x minus 1. Now if you want, so obviously whenever you do a substitution, put in parentheses and then put what you're substituting inside the parentheses. You can distribute here 3 times x and 3 times -1, so this is 3x subtract 5. All right, 2. The absolute value of x divided by x. So if I plug in 2, the absolute value of 2 divided by 2 is 1. G at -2. The absolute value of -2 divided by -2. Well, the absolute value of -2 is positive. It's still +2 divided by -2. So this one's going to give the answer -1. And then, just for fun, evaluate at x squared. Whenever you square a number, it's always positive, unless it's 0, but even there. So these bars actually are not needed, and then you could actually simplify this all the way down to g at x squared. Oh, haha, that should be x squared, right? And then you can simplify this to 1. I was trying to figure out what was happening there. Number 3. All right, this will be the good challenge. This is setting you up for the limit definition of a derivative, which we'll be doing sooner or later here. Now, that's called delta, what I just drew. So that's x plus the change in x, subtract f at x over the change in x. So how do I use f at x to find that? So wherever there's an x, I'm going to put in x plus the change in x. So put the lights on. Here, put that into the, so instead of x squared, you put this in squared. Instead of x, you put in this. And then subtract, use parentheses. What's f at x? Well, you just put that in, x squared subtract x. And then the change in x, you can just leave that as the change of x. There's nothing to substitute in there. Now we do a little bit of algebra and simplifying from what we did. This is a distributed question, so if you need to, some people like doing this when they FOIL. And then we start multiplying. So this is x squared. This is the change in x times x. And this is the change in x times x. So you have 2 of them. And then this is the change in x squared. I'm going to distribute that subtract sign. Now I want you to notice this. X squared, take away x squared. What does that leave me with? There's just an x there, right? you know what I forgot? I forgot this part. So minus x plus the change in x squared. So x, take away x, now that's gone. I was wondering what was happening. Then notice they all have a change in x that I can factor out. This gives me 2x plus the change in x plus 1. And then these can cross out, and that's what you're left with. That's your answer. 2x plus the change in x. Is it plus 1 or minus 1? So this should have been, negative x squared plus, right? This one, right here. So it should have been negative x negative. This one right here should have been a minus sign. There it is. I know, right? A little confusing. Moving on. It's okay. Number 4. In question number 4, without using a graphing calculator, find the domain and range and draw its graph. So f at x equals the square root of x plus 1. And then when possible, make use of the parent graphs in this lesson. So for this one, the parent graph is the square root of x. So I'm going to change that to what I see. So I want you to notice the change that took place is under the square root sign. It's inside the function. And it affects the x values, the domain, and we'll do the inverse of what we see. So we're going to subtract 1 to all the x's. So for the parent, 0, 0 is the starting point. And then the square root of 1 is 1, and the square root of 4 is 2. And we're going to change these points. So I'm going to plug in 0 for x. I'm going to subtract 1 to all the x's. But the y's are going to stay the same. And those are the points that I'm going to graph. So we have negative 1, 0. We have 0, 1, and 3, 2. So that's what the graph looks like. It also asks for the domain and range. Now the domain and range comes from the starting point. So we can do it in interval notation. So in interval notation, it's negative 1 to infinity. That's the domain. And the range goes bottom to top is 0 to infinity. Number 5. In number 5, we have g at x equals x squared plus 2. And I want to be able to graph that. So I want to understand the parent graph. So the parent graph is y equals x squared. Make sure it wasn't too important here. Just here. All right. So the parent graph here is just x squared. The points on the parent 0, 0, 1, 1, and 2, 4. If you square 2, the answer is 4. I want you to notice that you're adding 2 on the outside of the function. And so if I want to change this to what I'm graphing, the y coordinate is going to change. You're going to add 2 to the y, but the x is going to stay the same. So I just want to add 2 to the y coordinate. And then that's what I'm going to graph. So I have 0, 2, 1, 3, 2, 6, And the nice thing is this is symmetric, so we can do it, we can make it this way and that way. Now, so there's the graph of the parabola. It's been shifted up too. The domain of all quadratics is all real numbers. And the range, the lowest y value there is 2. So it goes from 2 up to infinity. Number 6. It's just a line, so I'm not going to be too complicated about it. So if I graph this line, I'm going to start at positive 4. That's the y-intercept. And then the slope is negative 1. So I would make it more complicated, but I just don't feel like it. So there's the slope. It starts at positive 4. The slope is negative 1. The domain and the range are all real numbers. Oops, negative infinity to positive infinity. It's all real numbers for both. That's number 6. Number 9. Number 7. Why did I get to number 9? I don't know. Number 7. So in question number 7, it says, without using a calculator, determine whether y is a function of x. And so how we do that is we solve for y. So if I want to get y by itself, I would subtract 2x, and then I would divide everything by 3. So the question is, can you rearrange it? Can you get y as a function of x? Can you make it look? And the answer is yes. So this is definitely a function. If I look at 8, what's going to be it? Can't I just do that every time? And I'll show you what's going to happen. So x squared plus y squared equals 4. So you can subtract x squared, but the problem is when you take the square root, the answer could be both positive and negative. Because of that, the answer is no, because we actually have 2 functions there. So because it's positive and negative, that's what makes it no. It's not a function. Number 9. In question number 9, it says use the parent graph of y equals root x. That's 0, 0, 1, 1. And the square root of 4 is 2. And it says graph the following. So if I want to graph a, let's just get right to it. Oops, y equals the square root of x plus 2. So I know that this just takes the graph and the y values are going up 2. So it's going to go 0, 2. It's going to go 1, 3. And 4, 2. 4, 5, I mean. So everything just got shifted up 2, and that was the graph. For B, the negative in front is a reflection, and it reflects across the x-axis. So how does that affect the graph? So if it reflects that way, it's the y values that are negative. So 0, 0 would stay the same, but this would be 1, negative 1. And this would be 4, negative 2. C, the square root of x minus 2. Because it's inside, it affects the x values. And it does the inverse of what it says. So we're going to add 2 to the x values. So that's 2, 0. That is 3, 1. And add 2 to the x, that's 6, 2. So it's just been shifted 2 units to the right. Part D. Here's an example where the y-coordinate has been multiplied by 2. So 0 times 2 is still 0, 0. But the y-coordinate, 1 times 2 is 2. So I'm going to find 1, 2. And then again, you're going to take the y-coordinate times 2. So 2 times 2 is 4. So it's 4, 4. And that's what it looks like. In number 10, use the parent graph. to determine an equation for each graph. So for 10a, if I think of the parent graph, the vertex at 0, 0, so it's been shifted to the left 3. And when I look, it hasn't been shifted up at all because 0, it stayed there. And is there any stretches, or does it look skinnier or wider? And the answer is no. So everything else, the only change is to the left 3. So what would that equation look like? So it would be x plus 3 squared because it's been shifted to the left 3. If I look at part B, look at the vertex. Instead of at 0, 0, it's been shifted up 2, and the shape hasn't changed. So that's the only thing. So for B, if it's been shifted up 2, it's x squared plus 2. So see the difference when it goes to the left compared to when it just goes up. So the parentheses matter. Number 11. In number 11, f at x equals the square root of x, and g at x equals x squared minus 1. So some algebra practice with compositions. So in this example, you start inside to outside. So first start with g at 1. So plug 1 into g. 1 squared, take away 1, and you get the answer 0. Then you take that answer, and now you take that answer and evaluate it with f. So the square root of 0, and the answer is 0. B, g at f at 1. Remember, start inside. So start with the f evaluated at 1. So the square root of 1 is 1. And then go to the g function and plug in 1. 1 squared is 1, take away 1, and the answer is 0. Part C. Now that means composed by. So if it's composed by, it's a substitution question. F is composed inside of g. So f is the square root of x. So instead of x squared, we're going to take out x and put in parentheses, and then whatever f is goes inside this place. So this is the square root of x squared, take away 1. So the square and the square root, they undo each other, so the answer is just x subtract 1. D, there's no D. 12. In question number 12, two different functions. F at x equals x plus 1. G at x is 1 over x. And now the question is, find the following. So if I want f composed by g, and then what's the domain? So f composed by g means g gets plugged into f. So it becomes 1 over x plus 1, and you can tell that x can't be 0 or else it would be undefined. For the second one, I guess that's part B. So this is A and B. For C and D, it's g composed by f. So now f gets plugged into g. So take out the x and put in x plus 1. And then now what's the domain restriction? And realize that x can't equal negative 1 because that would make it undefined. Number 13. Are the two composite functions from problem 12, are they equal? The answer is no. Not the same, right? So 1 over x plus 1 and 1 over x plus 1 are not the same. Well, that's a simple answer there. Number 14, you're given a bunch of functions. So I'm not even going to write them all down. So we have k at 2. So into the k function, k at x just equals 3. There's no variables, so no matter what you plug in, the answer will always be 3. For b, f at k at x, since k at x is always 3, what you're really evaluating is f at 3. And when you plug 3 into the f function, it's 3 squared, which is 9, and then times 2, which is 18. If I look at part C, what we got? F composed by f at x. Since f is 2x squared, take out the x and put in parentheses, and then inside is itself, which is 2x squared. So it's inside itself. If I evaluate this, 2 squared is 4, and then the exponents multiply. So altogether, this is 8x to the 4th. For part D, k at g at x. So again, for this one, we're taking g and plugging it into k. Now, no matter what you plug into k, the answer is always 3. So this answer is 3. E, g composed by h at 3. So that means I'm going to take 3 and plug it into h and get an answer. So 2 times 3 is 6. Take away 7 is -1. And then take the answer -1 and plug it into g. So -1 plus 5, so the answer is 4. So again, take 3 and plug it into h and get an answer. That answer is -1. Then take -1 and plug it into g, and that answer is 4. All right, last page here. 15, find the inverse. Now, in order to find the inverse, x and y are inversed. And now solve for y. So I'm going to add 1 and then divide everything by 2. And then the symbol for inverse, once you get a y by itself, is that symbol there. For number 16, start with, if you need to recognize that we need to write it with a y instead of f at x. So y equals the cube root of x minus 1. Then do the inverse. So x and y are inversed, and now get y by itself. So we're going to add 1. The inverse of cube root is just to cube both sides. And now that y is by itself, now you can use the symbol for inverse, and that's the symbol. Number 17. For number 17, g at x equals x. So if I inverse this, it's the same thing, right? So if I write y equals x and inverse it, that y is by itself. So a function and its inverse are equal to each other. There's your answer, number 17. Number 18, I'm going to write it first as y equals the square root of x. To inverse it, I inverse x and y. And then to get y by itself, I square to get y by itself. But there is a restriction here. So if I look at the beginning in terms of what's happening, the y value and the x value, both the x and the y have to be greater than or equal to 0. So if I inverse it here, you can't have a negative number here, or the square root of a negative number is imaginary. So there is a restriction there. Number 19. Number 19 says, draw a graph of h at x and the inverse of h at x from problem 18. So if I graph y equals the square root of x, I know what that graph looks like. That's that. If I do the inverse of that, then I'm graphing y equals x squared. Well, that's a parabola, so I know what that looks like. But I'm only going to draw it when x is greater than or equal to 1. So if I draw that. Now, do they want you to draw it on the same graph? And it did include the domain restriction, right? So that was the idea, that it's only these x's and this. So it's not the full parabola. And when you draw both of them on the same graph, they reflect over the line y equals x. Number 20. In number 20, f at x equals the square root of x subtract 2. G at x is x squared. H at x is 1 over x squared. And what we're going to do for each one, for A, it says find g at f at x. So in other words, take f at x and plug it into g. So that's what I did. The square root and square undo each other, so you're just left with x minus 2. And then it says, what's the domain restriction? But for the restriction, you have to go back before you simplified it. So if I look at the square root here, x must be greater than or equal to 2, or from 2 to infinity. So you have to look before you simplify it, because you can't put any number smaller than 2 here when you do the work. Part B, h at f at x. So again, I'm taking f at x and plugging it into h. So take out x and put in the square root of x minus 2. So it's the square root of x minus 2 squared. If I simplify this, it's just 1 over x minus 2. So it's important to know that here, x must be greater than 2. Here, x can't be 2, because it would be undefined then. And so this answer is actually this. X is greater than 2, because it can't equal 2 within that fraction. So for this, it would use parentheses in terms of what the domain restriction would be. All right, number 21. In 21, without using a calculator, can you graph a piecewise function? Let's do that together. So that's x plus 2, that's negative x, and that's x squared minus 6, and then the restrictions that go with it. And how would you graph it? So to graph this, start with negative 2 and plug it into the top piece. That gives you the answer 0. So at negative 2, 0 is a hole in the graph. That's because there's no line underneath the arrow. And the slope of this line would be up 1 and over 1, but we only want this part of the line. So here's the line that goes here, and the slope is up 1 over 1, but I'm only drawing it up to negative 2. So to the left of negative 2, this line has a slope of up 1 and over 1. The next, from negative 2, can you plug it into negative x? Now a negative times a negative makes it positive. So at negative 2, the answer is positive 2. So it's right there, and it's a point. And then do the same thing. Plug in positive 2, and you get the answer negative 2. And then connect these together. It goes through the origin. Recognize the lines underneath the arrows. That makes them points, not holes. Plug 2 in here. And you get the answer, what? 2 squared, 4 take away 6, negative 2. So 2, negative 2. There it is. So it shares. And then it's a parabola folding up. Now negative 6 would be where the vertex is. So it's just folding up from there. So just draw a parabola folding up from there. So there's the graph of that piecewise. Number 22. In number 22, you're given a function. This is called a rational function. And you're asked to find the zeros without using a calculator. So the first thing I need to know is I need to factor this. So the numerator factors with negative 1 and negative 2. They multiply to 2 and add to negative 3. The denominator factors as a difference of squares. So the square root of x squared and the square root of 1, there it is. Now for x-intercepts or zeros, I have to remove the hole. That's what this would create, a hole. We need to remove it. So the only x-intercept is from the numerator, and that answer is positive 2. And the reason it's positive 2, take away 2, because that gives you the answer 0. So there's only one x-intercept, and it's at positive 2, or 0. For 23, g at x equals 2x cubed, subtract 8x. To find the zeros, you make it equal to 0. To solve this, we're going to solve it by factoring. So what do they both have in common? 2 and x. So what's left over is x squared subtract 4. I'm going to keep factoring it. That's a difference of squares. So the square root of x squared and the square root of 4. And then each factor has an answer. So 2x, the answer is 0, negative 2, and positive 2. So those are the zeros of that function. If I graphed it, that's where they would cross the x-axis. 24. Almost there. At 24, it says use the graph that's given to draw an accurate graph with those changes that are involved. So I need a sense of like what are the important points here and what did this do. So if I see a negative on the outside, that's a reflection and it reflects over the x-axis. So whatever is above reflects down and so on. So let's just start there. So if I have a sense where I can show you both at the same time, kinda. So if I look here, I want to reflect that down. So it's going to be negative 3, negative 1. Negative 2, that will stay the same. Here, negative 1, negative 1, this is going to reflect up to negative 1 and positive 1. So this is just going to be connect as a line. It's going to connect to 0. Now I'm going to reflect this point up to positive 2. And then this point is going to be reflected down to 2, negative 1. All right, there's 24. All right, number 25. So this is y equals negative f at x. So that reflected over. Take each essential point and reflect it over the x-axis. Practice again. So y equals f at negative x. So when the negative's on the inside, it reflects the other way. It reflects over the y-axis. So let's do that. So what's on the left will be reflected over to the right. So this becomes positive 3, 1. I'm going to reflect this one over. That is, this one over on this side be positive 2, 0. This would be positive 1, negative 1. And that makes a line. And then this one will stay the same. Oops. 0, 0 doesn't get reflected. And then on the other side, this side gets reflected over on this side. So this becomes negative 1, negative 2. And then this last point, 2, becomes negative 2, 1. And I just want you to see how it's been reflected over. All right, 26. In 26, and I just want you to be able to see the original as I'm doing it, the absolute value bars makes everything negative becomes positive. So everything negative becomes positive. So I'm going to negative 3 and 1 stays. Negative 2, 0 stays. But the next one is negative. So that becomes up to positive 1. And then it connects again to 0. And then this point gets reflected up to become positive. So 1, positive 2. And then this one stays the same. So this one's at 2, 1. Did I forget something? No. Oh, I know what I did. So there's, do you see this? Oops. Do you see this x-intercept? I didn't do that one. So that was like right there. So it goes like this and like this. So ignore this little part. All right, number 27. In number 27, the absolute value bars are inside. That's a little more trickier when they're inside, but we'll do it together. So when they're inside, what's on the right, the positive x value stays, and you erase the left completely. So just redraw what's on the right. So that's this first step. So I'm just going to draw what's on the right side only. So I need 1 and negative 2, and I need 2, 1. So just redraw this part. So just the right side, and then you reflect that over on the left. That's what the bars do. So just draw the right side and then reflect that right side over. So that's negative 1, negative 2, and negative 2 and 1. There it is. Kind of looks like a W. 28. In number 28, f at x subtract 1 means you just take every point and shift it down 1. So this first point goes down to negative 3, 0. And then this point goes down. And this point goes down. This point goes down. This point goes down to negative 3. And then 2, 1 becomes 2, 0. Oops. These are all line segments. 29. Now it's inside the function, so we're going to add 1. It's been shifted to the right 1. Ha, my light. So take each essential point and shift it to the right 1. So this to the right 1 becomes negative 2, 1. And then to the right 1, this becomes 0, negative 1. To the right 1, that becomes 1, 0. To the right 1 becomes 2, negative 2. And then to the right 1, that becomes 3, 1. So it's the same picture, it's just been everything's been shifted to the right 1. All right, number 30. In question number 30, 1/2 f at x. That's taking the y values only and halving them. So let's see what that looks like on the graph. So if I half the y values, so it's negative 3, but now it's just half because it's been halved. Here, it's negative 1 and half. Here, the 0 doesn't get halved, so it stays at 0. Here, the y value gets halved, so it's at negative 1. And then this gets halved, so the positive 1 becomes a half. So it's a similar picture, it's just been kind of squished down a little bit. That's number 30. 31. What happens when it's 1/2 inside? And it does the inverse. So the x values you're going to multiply times 2. It's going to be a lot wider. So negative 3 times 2 is negative 6. So it's negative 6 and 1. This becomes negative 1 times 2 becomes negative 2 and negative 1. Well, here, this one I should say. Yeah, that can just do this point. So negative 2 and negative 1. This would have been negative 4, so it will go through negative 4. It connects still with 0. Take the x value and double it, so it's 2 and negative 2. And then the last one is 4 and positive 1. So it's all been stretched out to the right. All right, last one. Like this, 32. We're almost at the end. So 32, the absolute value bars and a shift. So what this means, shift it to the right and reflect it. Oh, sorry, shift it down 1 and reflect it. So first we're going to shift it down 1, and then we'll make it all positive. So if you shift it down 1 to begin with, and then make it, so shift it down 1 and then make it positive. Let's see if I can think through that with you. So if I shift it down 1, it's going to stay there at negative 3 because it's 0. You can't reflect that. This one, if you shift it down, it goes to negative 2, but then you're going to reflect it up to positive 2. So there's that part. 0 goes down 1, but then gets reflected up to positive 1. This one goes down to negative 3, but then gets reflected up to positive 3. Right here, it's going to go, so between 1 and 2. And then that value would stay well, you're going to shift it down 1, right? So everything gets shifted down. So sorry, if you get shifted down, that goes right here. So it actually connects right here. And when it's on the axes, it can't be reflected. So it's right there on the axes. So there's working with transformations a little bit differently. All right, let's end this. We're going to use a calculator. I love using a calculator. I want you to love using a calculator when you get a chance. Not like photomath, but an actual calculator and know how to use it. F of x equals negative x cubed minus 3x squared minus 2x plus 4. And the question is to find the zeros. So to find the zeros, we make it equal to 0 and solve it. So let's do that on the calculator. So here's our calculator. See if it'll zoom in. I want you to press menu, then algebra, then solve. And you're going to type it in. X cubed, subtract 3x squared, subtract 2x plus 4, equals 0. And we're going to go comma x. That tells the calculator solve for x. And then go control enter. And you have your answers. So, what answers did I get? If I look carefully, I have negative 1.236, 1, and 3.236. So there's 3 answers. I'm going to write each of those answers down here. Whoop. The camera got real big, so I got to move it over. Sorry, so the answers again were negative 1.236, 1, and negative 3.2, positive 3.236. So again, these are the answers we're looking at. Just writing them down. While I'm here, I might as well do the other one. Can you solve this equation? Since I'm here, algebra, solve. Oops, let's get down here, let's do it again. Menu, algebra, solve. And now the equation is x cubed subtract 2x squared plus 5 equals, just type it. Square root sign is with x squared, so it's in blue, so you press Control and then x squared. 3x plus 10. Make sure you move the cursor. Now you have to go comma x, so it tells the calculator to solve it, then Control Enter, and you have your answer, negative 0.890. Let's write it down. So write down what you did. And then I keep forgetting the camera's like super zoomed in. So we used the calculator, found that answer. All right, 3 left. 35. The domain and range. It says use a calculator to help you. So if I use a calculator to help me here, let's practice graphing for the domain and range. So I have something here. So I'm going to press Menu and then Actions, and then I'm going to delete what I have in case you have something. Go, yep, I just want to delete it. So start from scratch. And so press Tab, and then you're going to type in 2x squared plus 3x plus 6, and then look at the graph. So do you see the vertex? That's all we need for the domain and range. So the domain is all real numbers, but I need that vertex for the range. So I'm going to press Menu. I'm going to analyze it. I'm going to find the minimum. That's 2. So I'm going to move it to the left, and I'm going to move it to the right. I'm just looking for the x value of the minimum. So actually, I'm looking for the y value of the minimum. So I have 4.875. Do you see that for the y value? So for the x's, the domain, so again the equation was y equals 2x squared plus 3x plus 6. It's a continuous function. There's all numbers. So what you're thinking of for the domain, is there any number you can't plug in for x? And every number works to get an answer. So it's all real numbers. For the range, when I look off the graph, the lowest y value I just said was 4.875. So it goes 4.875 to infinity and beyond. 36. For question number 36, it's y equals the absolute value of x minus 2 divided by x minus 2. Real tricky. Is there an x value you cannot plug in here? And the answer is you can't plug in positive 2, I don't believe. That gives you a bad answer. So for the domain here, the only answer x value you can't use is 2 because that makes it undefined. If I look for the range, what are the possible values? Let's look off the graph real quick. So I'm going to press Tab. I'm going to erase what I did before. I'm going to go Control Divide for a fraction line. Now, if I want to get the absolute value, the button beside the 9, do you see that one? That brings up a bunch of functions, including the absolute value bar. So do you see how it's already highlighted? The absolute value bar. So press Enter, and then type in x subtract 2. And then in the denominator, we're going to type in x subtract 2. And then look at the graph. And if you look really carefully at the graph, what I want you to notice is the only y values are positive 1 and negative 1. And at positive 2, it's undefined. So the range for this is positive 1 and negative 1, just two numbers. 37, last one. We got this. Y equals the square root of 7 minus x squared. There's different ways to do the domain and range here. No, if we did it off the calculator, let's look at it. Press Tab. You can erase what we did before. It's the square root of 7 subtract x squared. When I look at this graph, See if it'll focus in there. What do we get a sense of? So let's focus in first of all. Let's get rid of this. So do you see the graph right there? It's just like almost looks like part of an ellipse, right? In terms of what you're looking at. Focus in, focus in. And so what I need to know for this, for the domain and range. So for the domain, I need to know the left and the right. And they're right on the axes. So I'm going to go menu, I'm going to go analyze and find the zeros so I can find the least and the greatest. So for this one, if I go left to right, the smallest x value is right there, negative 2.645. I don't know why my camera starts to get a little fussy in terms of focusing in. So negative 2.645. And then I need to find the right side there. So the 0 on the right side. So I'm going to press menu and I'm going to again press analyze and 0. And then I'm going to move it to the left and press down on the pad, move it to the right and move down, press down on the pad. And the other one's negative 2 point. So one is negative and the other is positive. I think they're the same. Let's move the one I did before so you can see it. So can you see one's positive and one's negative? So the other one's positive 2.645. You don't have to round. And then the range, that's the y value. So the bottom y value is 0. And so now it's just a matter of what's the upper y value there. So I'm going to find the maximum for that. So I'm going to go menu, analyze, and I want to find the maximum. So that's number 3. And I want to move it to the left, I want to move it to the right, and I want to find out what that maximum value is. So what is that maximum value? Right there. And it says it is, oh, it's the same number. How fun is that? So it's 2.645, that y value, that's the max. So it goes 0 to 2.645. So there's the domain and the range using a calculator. All right, Mr. G Math over and out. I'm proud of you for completing the assignment. Until next time.